Let's look at an example of solving a triangle that fits within a law of sines situation. So in this case, we want to solve the triangle where we're given angle A is 40 degrees, angle C is 65 degrees, and side B is 20. Okay, so with all of these problems, I would strongly encourage you to try and draw a triangle, draw what the information, or at least try to draw a triangle that fits the information. It does not need to be the scale, although that can sometimes help, but let's just try and just draw a triangle. I will often draw pretty much the same triangle every time. Okay, so just kind of a horizontal side, and then two sides angled upwards to meet it at the top. Okay. In this case, we can put the angles and label the angles and sides wherever we want. I usually try to put the known angle in the bottom left. So in this case, I'll use angle A and say that's 40 degrees. Where the others go is just, it's all relative. It's up to you. Doesn't matter. So I'll put B on the bottom right and angle C at the top, which we know C is also 65 degrees. And we know side B. So if angle A is the bottom left angle, then side A is the top right side. If angle B is the bottom right, then side B is the top left. And if C is the top angle, then side C is the bottom side. Okay, so in this situation, we are given angle A is 40 degrees, angle C is 65, and side B is 20. Okay, so that's the information that we're given. I think it's then helpful to look at that information. What are the values that we have? Which case of the law of sines, law of cosines, which case are we looking at? Okay, so in this situation, again, looking at our triangle, we are given two angles and the side. Now, in this case, the side is the side connecting the two angles. It's the side between the two angles. And so that means, just looking at that we are looking at an angle side angle, or ASA case. All right. And so we know angle side angle is a law of sines case. So you need to figure out which case you're looking at so you can know whether to do law of sines or law of cosines. All right. And again, ASA is law of sines. All right. So the law of sines formulas, we have sine of angle A over side A is equal to sine of angle B over side B, and then sine of angle C over side C. So that's our general formula for law of sines. So let's go ahead and put the values in there that we know. So we know angle A is 40 degrees, so that gives me the fraction sine of 40 degrees over A, but I don't know side A. For the B's, I know side B, so I'm going to have the sine of B, angle B, over side B, which is 20. And then for the third fraction, the C's, I know angle C. So sine of 65 degrees over side C. Okay, so looking at each of these fractions, in each fraction we have one known value and one unknown value. Okay, and that doesn't help us. Okay, in order for us to actually solve anything here, we have to have one fraction with both values. Okay, now in this situation, it's easy to get because we know that the sum of the three angles has to be 180 degrees. Okay, and that's always going to be true. The sum of the interior angles of a triangle is always 180 degrees. So A plus B plus C has to be 180. That means 40 degrees plus B, which is the unknown, plus 65 degrees has to be 180 degrees. Okay, 40 plus 65 combined together to give us 105. So B plus 105 degrees has to be 180 degrees. And we finish solving for B, and we get 180 minus 105 gives us 75 degrees. So we now know all three angles. Okay, that 75 degrees is not one of the given information, so it doesn't determine angle side angle, but it's easy to find. And once we find it, we can go back into our fraction here where we have sine of b. I can replace that b with 75 degrees. So for the b fraction, I have sine of 75 degrees over 20. And now that I have one fraction solved, I can go ahead and solve for the two unknowns. Okay, and so to do that, just take, so if we want to find side A, take the A fraction and set it up as a proportion with the B fraction. So our proportion will look like the sine of 40 degrees over A is equal to the sine of 75 degrees over 20. Okay, and to solve a proportion, you just cross multiply and divide. So if we cross multiply, that's going diagonally here, we'll get, we'll have A times the sine of 75 degrees is equal to 20 times the sine of 40 degrees. All right, we want to isolate A, so we're going to divide that sine of 75 over. So we have A is equal to 20 times the sine of 40 degrees over the sine of 75 degrees. All right, and that's something we can just go to our calculator or other form of technology and compute. So we have 20 sine of 40 degrees divided by the sine of 75 degrees. And that gives us a value for A equaling 13.31. And that's rounded to two decimal places. It's technically a little longer. If we looked at more digits, it's 13.309. 254, and it continues going forever. Okay, but we'll just, for now, we'll round it to two decimal places of, so A equals 13.31. So we have found the unknown angle, B is 75. We have found the unknown side, A is 13.31. The only other thing we need to find is side C. So to find side C, again, use the fraction for angle in side B, and then use our C's fraction. So we're going to have the sine of 75 degrees over 20 is equal to the sine of 65 degrees over side C. Cross multiply. If we cross multiply, we're going to have C times the sine of 75 is equal to 20 times the sine of 65 degrees. And then we're going to divide that. So C will equal 20 sine of 65 degrees over the sine of 75 degrees. And so we're just going to take that again, plug it into our calculator. So 20 sine of 65 degrees divided by the sine of 75 degrees is going to give us roughly 18.77. Again, that's rounded to two decimal places. All right, so we were given angle A, side, angle A, angle C, side B, and we've been able to find the missing angle B, side A, and side C.